Okay, this question is about optical resolution. This is question 4 in the HL physics paper. And again, you've got a nice diagram at the beginning there showing 2 point sources of light, and the light travels through a slit, and we get some images on a screen. And we start off, one of these is covered. Point B is covered, and it wants you to sketch a graph to show how the intensity of light from the source of point source A varies with distance on the screen. So we're looking for a single slit diffraction, and what we get should look something like what you drew in the last question. So we're looking for something like this. I'll put it here. It's a bit simpler than the last question. I'm sure that's correct. Only 2 marks. General shape is important, but just make sure again that the lines touching the axis here and here, and again the height shouldn't be more than 1/4 of the central maximum. Just 2 marks, so a bit easier to get those. Now it says point B is uncovered, so now you have both light sources on the screen, and it also tells you that they're just resolved, and that's a key point. That if they're resolved, they should be a certain distance apart. The two maxima should be a certain distance apart. So again, using the axes, sketch the graph now of how the intensity of light from the second source varies with distance on the screen. So it's asking you to draw apparently a very similar shape, but it will be in a different place. So we grab this one over here, and we're looking for exactly the same shape, but they need to be resolved. So one needs to be shifted along a little bit from the other one. So we're looking for this. So this time you've got this one from A and this one from B. You should have drawn them both on the screen. The maximum is smaller on this one, but it's the distance apart that is really important. Otherwise, you're looking for the same shape. Again, that's just 1 mark, so really easy, just showing that you draw it shifted along either A to B or B to A. Not really important. And the last part's a nice question, but it is a topic 9 question. So this time you're looking at 2 stars very far away from Earth, and it tells you the distance of the stars from Earth is 8.1 times 10 to the 16 meters. And it says that we can just resolve those 2 stars as separate images. So again, that's giving you an important piece of information there. If we can just resolve them, we know how far away they are, and we know the wavelength emitted by the stars, and we know the size of our telescope, the objective lens of our telescope, then we can use the Rayleigh criterion, which is a formula in topic 9. I think the last topic in 9, wave phenomena. So this is the Rayleigh criterion, and it's a nice little piece of maths. There are 2 pieces of maths actually that you need to complete the question for 3 marks. First of all, this is the Rayleigh criterion. This is what you get in your formula booklet. So if you spotted this, then you're on your way. Plug in some numbers. 1.22 is a standard factor we have to apply because it's a circular objective lens rather than a square objective lens. So the 1.22 is in your formula booklet. 5.5 times 10 to the minus 7 is the wavelength, and 25 times 10 to the minus 2 is the objective lens diameter. So those numbers need to be plugged right in, and that you need to take into account, of course, this is centimeters. You need to turn it into meters. And that gives you your answer in radians, which is the angle between the 2 stars. So that's something you might remember, parallax, for example. You might learn that. You might be able to figure that out with parallax some other way. But we can figure it out this way, and it's 2.4 times 10 to the minus 6 radians. Then you need your second little bit of maths, because you should know that the angle between 2 points in radians multiplied by the distance to one of the points will give us the distance between them. So with another little bit of maths, you can work out x, which is the distance between the 2 stars, which is 2 times 10 to the 11. And that's how you do question 4.